Welcome to another video of time value of money. In this video, we'll understand the present value of a growing perpetuity. Now, what is a growing perpetuity? So, a growing perpetuity is a series of periodic payments that grow at a proportionate rate and are received for an infinite amount of time. So consider growing perpetuity as a growing annuity which does not have an end date. So let me draw a growing perpetuity on a time scale. 0, 1, 2, 3, 4 and so on. So this will keep on going up to infinity. Now let's say the first payment is A. The second will be A into 1 plus G, where G is the growth rate. The third will be A into 1 plus G square. Fourth will be A into 1 plus G cube, and so on. Now let's say for this perpetuity, the rate of interest per annum is I%, and we want to find out the present value. In other words, how much should we invest today at I% interest per annum in order to get a perpetuity which has cash flows like this. So basically each of these cash flows will be discounted. Let's say this is PV1, second will be PV2, and so on. So basically PV will be equal to PV1 plus PV2 plus PV3 plus PV4 and so on up to infinity. Now this is equal to, so we know that future value is equal to present value into 1 plus I to the power n. So present value is equal to future value divided by 1 plus I to the power n. So this is equal to FV1 divided by 1 plus I to the power n1 plus FV2 divided by 1 plus I to the power n2 plus FV3 divided by 1 plus I to the power n3 and so on. Now FV1 is nothing but A. So A divided by 1 plus I. Now N1 is 1 in case of PV1 because PV1 is being withdrawn after 1 year. So the duration is 1 plus, now FV2 is A into 1 plus G. So A into 1 plus G divided by 1 plus I square, because this amount is being withdrawn after 2 years, plus A into 1 plus G square divided by 1 plus I cube, and so on. Now as we know, a geometric series is in the form of A plus AR plus AR square and so on, where the ratio of any two consecutive numbers is the same. So here let's say these two, so AR divided by A is R. Let's take these two, AR square divided by AR is also R. So let us find out if this present value of a growing perpetuity also is a geometric series. So let's take the ratio. So A into 1 plus G divided by 1 plus I square divided by A divided by 1 plus I. So A gets cancelled with this A. 1 plus I gets cancelled with this square. So this is 1 plus G divided by 1 plus I. Let's take these two. So A into 1 plus g square divided by 1 plus I cube divided by a into 1 plus g divided by 1 plus I square. So here a gets cancelled with this a, this square gets cancelled with this 1 plus g, and this gets cancelled with this cube. So this becomes 1 plus g divided by 1 plus I. So basically this is also in the form of a geometric series where a is the first term, which is a divided by 1 plus I, and r is the ratio of two consecutive numbers, which is 1 plus g divided by 1 plus I. So let me erase this portion. I have written down these two here. So for a geometric series like a plus ar plus ar square and so on, which is infinitely large, the sum is given as a divided by 1 minus r, where a is the first number of the series and r is the ratio of two consecutive numbers. So let's apply this sum here in our present value formula. So present value is equal to, now a is a divided by 1 plus I. So a divided by 1 plus I divided by 1 minus r, which is 1 plus g divided by 1 plus I. So this is equal to a divided by 1 plus I, and let's take the LCM here. So 1 plus I, this becomes 1 plus I minus 1 minus g. So this 1 plus I gets cancelled with this 1 plus I, and this 1 gets cancelled with this 1. So this becomes a divided by I minus g. So the formula for present value is a divided by I minus g, where I is the discount rate and g is the growth rate. So let us now take an example to understand this concept better. A company is expected to pay an annual dividend of rupees 66. Now the dividend stream is expected to grow at 10% per annum indefinitely. If the discount rate is 21%, what is the present value of the expected series? So let us draw this on a time scale first. So it is an infinite series, that means it is a perpetuity, and let's put the time frames here and so on. Now the first year dividend is rupees 66, and then the dividend is expected to grow at 10% per annum. So then for the second year it is 66 into 1.1. Then for the third year 66 into 1.1 square. For the fourth year 66 into 1.1 cube, and so on. The discount rate is given to us as 21%, and we have to find out the present value. So basically we have to find out how much money should be invested today at 21% interest per annum, which will allow us to withdraw this cash flow. So this is a case of finding out the present value of a growing perpetuity. And we know that the formula for finding out the present value of a growing perpetuity is a divided by I minus g, where a is the first payment, I is the discount rate, and g is the growth rate. So this becomes 66 divided by I, which is 21%. So we'll do 21 divided by 100, which is 0.21, minus G, which is the growth rate, which is 10%. So 10 divided by 100, which is 0.1. So this becomes 66 divided by 0.11. So 66 divided by 0.11. So this is equal to 600 rupees. So this is the present value of this growing perpetuity.